Welcome back, College Algebra students. We are in the very last section of our course. We're in Chapter 12, Section 7. We're looking at systems of inequalities today. In this video, we're going to be graphing inequalities and graph a system of inequalities. So just graph an inequality and then systems. So one of the things that we first need to take a look at is just a little bit of vocabulary. So one bit of vocabulary, just to point off to, is we talked about strict inequalities and non-strict inequalities. So the strict inequalities, when we're just less than or greater than. Non-strict is if we're the equal to. So when we graph inequalities, if we're the strict, they're going to be dashed lines or dashed curves. And if it has the line under it, then we're going to be a solid piece. So one way to try to explain this or identify that, if we have the line underneath it, then we've got a full line, whether that's a line or what we'll see later is a circle. It's a lousy circle there. Let's clean this up as a circle. If we were a strict inequality, then we might have a dotted circle. Okay? So those two are things just to keep in mind as far as a little bit of vocabulary. So let's graph an inequality. So as we take a look at this one, we want to graph x squared plus y squared is less than or equal to 4. Well, previously we have seen something like this. This is a circle where the center is going to be at 0, 0, and the radius is the square root of 4. So that's going to be 2. It's going to come out 2 all the way around here. And because this is a non-strict inequality, we're going to make this a solid curve all the way around. Now, how do we know where we shade? Because remember the idea of solving an equation or solving an inequality is what are the values for the variables that makes the statement true. When we solve, that's what we're interested in. Now, when we're graphing or when we're solving inequalities, often we go ahead and just do the graph because it's a little more descriptive here as far as what we have. So when we do our graph here, we basically split the graph or the coordinate plane into two pieces here. We have outside the circle and we have inside the circle. One way to figure out where we're going to be shading, what makes this true, is we just choose a test point. So choose a point that's clearly either inside or clearly outside, but not a debatable point. Not a point right up in here that might be, oh, where is that? Is that on the graph? Is it not on the graph? Clearly choose a point that's not. So if 0, 0 is available, let's use 0, 0. So let's choose a test point. If possible, 0, 0 is nice because 0 added to anything is just anything, and anything multiplied by 0 is 0. So let's see, if we choose this to be 0 squared plus 0 squared is less than or equal to 4, what we're checking is this true? If it's true, then we're going to shade wherever that test point is. If it's false, then we're not going to shade that piece. So 0 squared is 0, so 0 plus 0 is 0. That is indeed less than or equal to 4. That means then that we're going to shade inside where that test point is. And so inside this region then is the graph of the solution. Now, just to double check as far as outside the graph here, let's choose maybe 5, 0, okay, as a test point. So if I choose 5, 0, that'd be 5 squared plus 0 squared. Is that less than or equal to 4? Well, 5 squared is 25, 0 squared is 0. So that's just 25 is less than or equal to 4. That's not true. So I don't want to shade that piece. That is the overall kind of concept of what we're taking a look at here in this last section. Let's take one that's strictly just linear inequalities. So now we have a system here. Okay, so we have to graph a couple different items. We've got to graph both of these. So if I take x plus y greater than or equal to 2, if I solve for y, I'm going to subtract x from both sides. So I've got a slope of -2, so slope of -1, starting at a y-intercept of 2. So negative slope goes down 1 over 1. So I just fill in a number of these slots. And then because this is a or equal to, I'm going to go ahead and make this line solid. Now, let's go ahead. I'll get just a different color here. 2x minus y is less than or equal to 4. Let's graph this, or let's solve this in for y. So we'll subtract 2x. And then I'll divide by negative. So it's going to flip-flop everything. Oops. Make sure it looks like 4, not a y. That means it's going to start at -4, and my slope is 2. So up 2 over 1, up 2 over 1, 2 over 1. And because this is also or equal to, I'm going to make this a solid line. Then again, I can choose test points. So I got 4 different regions here. I could choose 4 test points. The other thing that I could do on this, instead of choosing 4 test points, so I could say in this equation, I want to be above the line. My y value is, y's are bigger than this. I want to be above that line. This one down here ends up being bigger than that, so I want to be above that line also. So is this that I want to be above both lines? The region then here is this spot in here. That is above both lines. Now, if I didn't like that technique, I can still choose test points. So if I would choose, for instance, 0, 0 is a test point. Is 0 plus 0 bigger than equal to 2? No, it's not. So this region out here would not get shaded in. Let's do maybe 2, 2, because that's clearly in this region. 2 plus 2 is 4, which is bigger than 2. That'd be 4 minus 2 is 2, which is less than or equal to 4, so that region would get shaded. Let's choose perhaps over here 5, 0. 5 plus 0 is bigger than or equal to 2, so satisfies that one. However, this would be 10 minus 2 is 8, and that is not less than or equal to 4, so I would not shade that region. Down over here, let's do 2, negative 3. So 2 plus -3 is -1, not bigger than or equal to 2, so I would not shade that. That would be this example. Okay, so that's what that would look like. Take a look at another system. So 2 others here, just take a look at. So you have part A and a part B. So let's take a look at part A first. We got 2x minus y is greater than or equal to 0. So if we solve this for y, I would subtract 2x. We got a negative, so reverse all the signs and reverse the symbol. So that's going to be 2x. So that's going to be starting at 0, a slope of 2, so up to over 1, or down to left 1. It is a or equal to, so that's going to be a solid line. Again, I'm going to change colors here. 2x minus y bigger than or equal to 2. So this would be, let's see here, I'm going to subtract 2x. Then again, I'm going to go ahead and reverse the sign, so I don't want a negative y, I want positive y. So it's going to be the same item. We just shifted 2 places up. So these 2 lines are parallel. So up 2 over 1, up 2 over 1, down 2 over 1, etc. Again, this one's solid also. Now we need to figure out where we are shading on this one. Okay, so on this one overall, notice that both of these are below the lines. Since I'm below both of them, what's below both then would be this region. So this overall is the region that I want to shade. Now, if I'm trying to choose test points, I can still choose test points. Let's choose a test point maybe up in here. This is 0, 5. If I choose 0, 5, let's see, 0 minus 5 is not bigger than 0, so that doesn't work. So this whole region is out. Let's do between these lines. Let's do maybe 0, 1. So 0, 1, 0 minus 1 is -1, and that is not bigger than 0, so that doesn't count. Let's use a point over here. Let's use 2, 0. So 4 minus 0 is bigger than 0, and 4 minus 0 is bigger than or equal to 2. So we do have it. Take a look at our test points, or we can gather those relatively quickly. Take a look at our next one. Again, let's take a look at another scenario. So x plus 2y less than or equal to 2. So that's going to be 2y less than or equal to negative x plus 2. When we divide by 2, we get negative a half x plus 1. So it's going to start at 1 here. It's going down, so down 1 over 2, or up 1 left 2. And again, both of these are or equal to, so I do want to go ahead and make a solid line. Let's graph the other one. We've got x plus 2y greater than or equal to 6. So similar process, going to subtract the x, then divide by the 2. So it's going to be negative a half x plus 3. So again, these two, just like the last one, are going to end up being parallel to each other. They have the same slope, they just have different y-intercepts. Now, when I take a look at just the inequalities here, the black one I want to be below that line, and the green one I want to be above that line. So when I take a look at this one, if I am, did I make a mistake in here? I just want to double check something real quick. Because the way it looks now, I would have no solution because I'm going to be below the black line and above the green line, and nothing is going to overlap there. So if that's the case, then I end up with no solution. So I just want to verify, just take a quick look again. Let's do our test points, see where we end up. How about 0, 0? So if I do 0, 0, 0 plus 0 is less than or equal to 2. That's okay, but 0 plus 0 is not bigger than 6. So this region is out. Let's do this test point, 0, 2. So 0 plus 4 is 4. That is not less than 2, so that doesn't work. Let's do 0, 5. So 0 plus 10 is 10, and that's not less than or equal to 2, so that doesn't work. So yeah, this one overall is a graph that has no solution. We are not going to graph anything in here because we have nothing that actually works on both of these. Okay, now this is what our homework will look like. Excuse me, what our homework will look like is an example like down here on number 8. Okay, now however, instead of taking a look at this one in the video here, what I want to do is I want to open up the homework itself, and I want to show you how we do the dotted and the solid lines and how we do the shading. So let's go ahead and pull this out here. So I want to graph x plus 1 less than or equal to -1 and x plus 5y greater than or equal to -5. So if I want to do those, let's see, x plus 1 is less than or equal to -1, and x plus 5y is greater than or equal to -5. So let me pull back here on my tablet. So we'll go ahead and solve these. This is going to be y less than or equal to -x minus 1. And this one would be 5y greater than or equal to -x minus 5. If I divide by 5, then I've got y is greater than or equal to -1/5 x minus 1. So these are the things that I want to be able to graph. So -x minus 1. Okay, let's take a look at that. So -x minus 1, I want to grab the line tool. So -x minus 1, come down here to -1 is our y-intercept. So I just click on that. And my slope is -1. So down 1, right 1. So as I do that, I can just click on that, and it snaps the line in place for me very, very quickly. If I want a solid line, I just leave it here solid. If I want dashed, I click on that one, and it does make it dashed then. This one, both of these were non-strict, so I want to go ahead and leave the solid lines. Now the other one, I had a line also, so click the other line tool. That also went through -1. It had a slope, however, of -1/5. So down 1 over 5 would be over here, and that would be that graph. Now, the other thing I want to do is I want to figure out where to shade. So I can grab the paint bucket here, and I can go ahead and figure out my shading. So I can go ahead and choose, in this case, let me choose 0, 0 as a test point. So back over here, it's a little darkened in, but we can still read that. 0 plus 0 is 0. That is not less than -1. So we don't include that. Let's take here, how about 1, 0? So 1 plus 0 is 1. That's not less than -1, so that doesn't count. Let's choose this point. That's 2, -2. So 2 plus -2 is 0. That's not less than -1, so this region doesn't count. Let's choose 0, -2. 0 minus 2 is -2. That is less than -1. See, 0 minus 10 is -10. -10 is not greater than or equal to -5. Okay, it's actually less than, so that doesn't work. So I think the only place we got left is over here. So hopefully this one works out, or we have no solution, which wouldn't seem to make sense because we've got to have a solution here somewhere. Let's choose -2, 0. So -2 plus 1 is less than -2. -2 plus 0 is -2, and -2 is bigger than -5. So this is the region we want to shade. So if we just click on that, it goes ahead and shades that in. I just click Save, check Answer, and fantastic, we've got it. Okay, so I wanted to show that so that we could see how to go ahead and put those in place. I want to also get on down here. Let's take a look at question number 9, because on here we've got a parabola. So I wanted to show the parabola. Move this off to the side. So with our parabola, use the parabola tool. This is x squared minus 7. So I know that I'm going to have my regular parabola. It's going to open up down here at negative 7. And so if I go ahead and do another point here, I know from the parent function, I would have been 1 to the right is going to be 1 up. So I'm going to be here. So that's going to be my parent function. Notice this one's strictly greater than. So I want this one to be dashed. And then I can do this next one. I got like y is less than or equal to x minus 4. So come down here negative 4. And my slope is 1. So it's going to be up 1 over 1. That one is solid. Okay, so that one's got to be solid. So where are we filling in? We can choose test points. We've got 1, 2, 3, 4, 5 different regions here that we have. So we could use 5 test points. The other thing that I would take a look at is I want to be above wherever the parabola is. And I want to be below the line. So above the parabola, below the line, ends up being this region. Fantastic. Now, if you don't like how I did that, as far as just above the line, or excuse me, above the parabola, below the line, we could have gone in here and taken a look at each of the test points. All of those work fine. Those would have been okay. As another example, let's squeeze down here, skip on down here to number 11. I want to take a look at number 11 because on number 11, we're given these different inequalities and then the options here as far as what makes sense, okay? So on these, what we can do is we can just start doing some test points. So if I want x squared plus 3, okay, x squared plus y greater than that, okay? I know I'm going to be greater than the parabola. So let's take a look at this one. Let me pull this, make it a little bit bigger. Choose a test point. If I choose 0, 8, for instance, clearly inside the parabola here. So 0, 8, let's see, here's the parabola. So I got 64, 64 plus 3 is 9. Is 0 bigger than or equal to 60, bigger than or equal to that? No, it's not. Oh, I'm sorry, I was doing 0, 8. I just did 8, 0 as a test point. Okay, so 8, 0 doesn't work because if I plug in 8, 0, this is 64 plus 9, 67. Is 67 less than 0? Is 0 bigger than 67? No. So 0, 8 does not work. So this equation is out. That graph is out already. Let's take a look at, so 0, 8, I was trying to go for 0, 8 instead of 8, 0. So if I do 0, 8 here, okay, 0, 8. So this would be 0 plus 3 is 3. Is 8 bigger than or equal to 3? Yes. Does it work in through here? Okay. So 0, 8, 0 times 8 is 0. 0 is not larger than 6. So this one's out. Okay. So what we have so far then, by choosing some test points, we know that this one's out because 0, 8 does not work. So this region here should not be shaded. We also took a look at this spot. This should not be shaded. Okay. So let's see, it's either going to be one of these two. I think it was going to be easier by process elimination. Let's take a look at this one. I'm just going to pull this out over here. Let's try this point. So this is the point 1. 1, 2, 3, 4, 5, 6, 7. So let's try 1, 7. So 1 times 7 is 7, which is bigger than 6, so it's okay here. And if I plug in 1 here, 1 squared is 1, plus 3 is 4. And my point was 1, 7. So is 7 bigger than or equal to 4? Yes, it is. So this is the one that I want. So I'm going to select that one. Check the answer. Fantastic. So this last question, when we get into the homework, that one's really going to be answered by doing all of our test points. Okay, and so now, if you don't want to choose the test points and do process elimination, we could go ahead and graph all these and do them by hand as well and see what works out, or we could try something different. Okay, but take a look at this parabola here. I want to be larger than the parabola. So larger than the parabola is either going to be this option because we're shaded inside the parabola, or it's going to be this one because we're shaded inside the parabola. So we kind of do some process of elimination a little bit if we happen to see that. If we don't see that, it's no big deal. We don't have to do those. We can still go back and do just the test points. Okay, so that wraps up chapter 12, section 7. Really short section as far as the ideas involved. We just have to graph our items, choose some test points, make sure we're careful about the dotted or the solid lines. That's the thing to be careful about. Other than that, there's not a whole lot to this particular section because we're doing our graphing. So if you happen to notice a mistake, please let me know. Otherwise, I will not see you probably in another video because this is the last video of our course as far as content. Now, thinking ahead as far as some other items for exams, might be another quick video about review for the exam and studying. So be on the lookout for that. But otherwise, thank you for a great course, and maybe I'll see you in another course.